Welcome to qnawire.
Okay, so for this problem, we have a plane traveling south at 35 meters per second, and we know the wind is moving at a rate of 10 meters per second um, in the southwest direction. Okay, so now for part A, it's asking in a vector addition diagram, we're going to show the relationship between the velocity of the plane relative to the Earth to the two given vectors. Okay, so basically we have to draw the vector of the plane and then the vector of the wind, and then we'll draw the vector of the plane relative to the Earth in reference to these other two vectors here. Okay, so let's do that then. Okay, so we have the vector of the plane here. So that is just pointing south, so it's going to be pointing in the negative y direction. So let's draw our quadrants here. Okay. Here we have the positive y direction and then positive x direction. Okay. So now the plane is going south, so that vector is going to be pointing straight down here. So this is going to be VP. And then we know the velocity of the wind is pointing southwest. Okay. So southwest is going to be here. So this is going to be the vector VW. So that means that the velocity of the plane relative to the Earth is going to be somewhere in between these two vectors here. Because you have the plane traveling south at some velocity, but then the wind is going to want to push it southwest. So that means that the plane is going to be somewhere in the middle, because the wind is going to have some influence on the plane moving southwest, but the plane is also traveling south here, so it's going to have to be somewhere in between here for the vector. So the actual velocity of the plane is going to be the vector of the plane relative to the Earth here. Okay, so it's going to be v of the plane relative to the Earth. And again, this is the actual velocity of the plane. Okay. So now we have the vector of the plane relative to the Earth's position here among the other two vectors. So now let's look at part B. So part B, we have to find the components of the vector of the plane relative to the Earth here. So we want its x and y components. Okay. So what we can do is we can actually draw a triangle here to find. So basically, we have to add the two vectors here. So we have to add VP and VW to get V P/E here. So we're doing vector addition here. So we have VPE is equal to VW plus VP. Okay. And then these are vectors, so we have to have the x and y components, or the I and j components. Okay. So what is VW in terms of I and j components here? Okay, so for that we could draw a triangle then. So we have, so let's draw it over here. Okay, so we know VW is in the southwest direction, so that means it's 45 degrees away from the south direction. So this angle here is going to be 45 degrees. Okay, and if we make a triangle here, we know that this is 90, and then this must also be 45 degrees because we have to have the sum of the angles added to 180. So if we have a triangle that has 45-degree angles here and then a 90-degree angle here, that means the sides here must be 1 and 1. And then using the Pythagorean theorem, we could find this side here would have to be square root of 2. Okay, that's just using a squared plus b squared equals c squared. Okay. Okay, so then using this, we could find the vector VW in terms of I and j components. Okay. So now we're going to use I and j components for VW here. So we're going to have the magnitude of it with the direction. Okay. So the magnitude is going to be 10 meters per second. And it's going to have I and j components here. It's pointing both in the x and y direction. So the components are going to be negative I hat over root 2. And that's because, so it's negative because it's pointing in the negative x direction here. And we have the division by square root of 2 because of the length of this side here. Okay. So that's where the square root of 2 is coming from. And it's going to be minus j hat divided by square root of 2. And it's negative j because it's pointing in the negative y direction here. And we have the square root of 2 because the length here is square root of 2. Okay, so now we have the vector VW in terms of x and y components. Now what about the velocity of the plane? Well, the velocity of the plane is just going south, so it's going the negative j direction. So then for this, we're going to have plus Vp, which is 35 meters per second. And it's going to be in the negative j direction because it's going down. Okay. So now what we can do is we can just add the I and j components here. So we have to add I together. Well, we only have one I component here, so we just have the one I component here. And so we have the I component, and then we have to add the two j components together. Because we have to add each component separately here. Okay, so if we have the I component here, we just have negative 10 over square root of 2. So I'm going to have negative 7.1 for the I component. And then the j components here, we have two of them, so we have to just add them together. So if we do 10 times negative j over square root of 2 plus a negative 35j, then we'll get the j component. So then I'm going to have a negative 42.1 for the j component. Okay. So then my x component is going to be negative 7.1. So it's the x component. And then my j component is going to be negative 42.1. Okay. So that answers part B then. Okay. And now we want the magnitude and direction of this vector here. So let's start another page here. Okay, so to get the magnitude, we just want to square both the components, add them together, and take the square root. So we're going to use this formula here. Okay, so then we just square both components here, add them together, and then take the square root. So we know from B that the x component is going to be negative 7.1, and the y component is going to be negative 42.1. So we plug in those for the x and y components, and we get a result for the magnitude. So the magnitude is going to be 42.6 meters per second. Okay. And then for the direction, we can use their equation for theta. So theta is going to give the direction. So we're going to have inverse tan of the y component of the vector, which we're going to have is v p slash e over comma y, and then divided by the x component. Okay, and then I could plug in these values. And I'm going to have an angle of 80.5 degrees. Okay, so since we're in the third quadrant here, so this quadrant right here, the angle that we're getting is going to be relative to the negative x-axis here. Okay, so this is going to be your angle. Okay. So we have an angle of 80.5 degrees relative to the negative x-axis. Okay, so something like this. So this angle here is going to be 80.5 degrees. Okay. So we could say that the direction is going to be 80.5 degrees relative to the west here, because the negative x-axis is going to be west. So we'll say relative to the west direction. Okay, so relative to the west.